Okay. So, hi everybody, I'm Rainer Sigwald. I'm a dev at Microsoft. I'm in part of the developer division. My main day job is working on the MS Build build engine, which is used in Visual Studio. So I work in close collaboration with the Visual Studio team and also with the .NET Core open source .NET team. So we've been open source as part of the .NET Core effort for many years. And I wanted to come and talk today a little bit about how we manage all of the open source code, how do we manage contributions, how do we manage shipping code out of all that stuff. We do it all in public, so I can tell everyone about it in a nice way, whereas I probably couldn't give this talk about all the internal stuff that we have. So first off, I want to talk about what open source stuff is there from Microsoft, and first, this is nowhere near all the open source stuff from Microsoft. Microsoft in general has open sourced a ton of stuff, including Visual Studio Code and things like that, that have nothing to do with .NET directly. So mostly I work on the .NET side of things, so that's what I'm talking about today. There's a ton of other stuff that I'm not talking about, and even within the .NET stuff, there's a ton of things that I don't know much about. And if I don't talk about your favorite .NET talk today, .NET open source repo today, I'm sorry. You're welcome to ask, but the answer will probably be, hi, I have no idea, what is that? And then I'm going to talk about some of the tools, techniques, practices that we use in the course of our day-to-day work. So what all is open source? The answer is a ton of stuff. So let's walk through. All of this is open source on GitHub. We'll talk a little bit more about what that means, but the main umbrella for all of this is the .NET Foundation organization, github.com/.net, and it has a bunch of other repos that are part of it. So there is, for example, Core CLR. Core CLR is the .NET runtime. In contrast to most of these, this has major pieces that are not written in .NET code because you need the actual runtime itself. When you're writing the JIT and the memory manager and the core runtime, that is mostly implemented in C++. But then there's also a lot of C# and .NET code that lives in this repo as well. This tends to be stuff for very core fundamental types. Things like string, definition lives here. There's also CoreFX, which is the base class library and other supporting core libraries. Things like system.generic.collections, things like crypto and HTTP request type things all live in the CoreFX repo. Also open sourced is Roslyn, the C# and Visual Basic compiler. So that allows you, this is the compiler that ships with Visual Studio. When you hit F5 in Visual Studio, you're running this code. And it also controls, the design of the C# and VB languages. If you want to propose a feature request, things like that, that's available online. Also open source, the .NET Core SDK. If you want to target, you want to write an application that requires a bunch of build logic, that uses my code, MS Build, that uses the code of other folks on my team that lives in the .NET/SDK repo. So this is a ton of build logic, tools, tasks in order to get your code running and to get it running on, to be able to build it using Linux, build it on a Mac, then ship the binaries to your Linux server in the cloud, or better yet, Azure Continuous Deployment, that kind of thing. Also open sourced is a ton of documentation about the .NET Framework and .NET Core. So there's a GitHub repo for this. That's where all the stuff is stored. But also, if you go to docs.microsoft.com/.net, you find a ton of documentation. And on every page, there is an edit button and a feedback button. The feedback button files a GitHub issue. The edit button opens up the markdown that controls this page in GitHub, and you can use normal GitHub processes to go in, propose an edit, send a PR to get your documentation changes produced. A new thing that has been recently open sourced is Windows Forms for .NET Core and Windows Presentation Foundation for .NET Core. Part of .NET Core 3, which is not yet released but is under active development, is enabling UI-driven applications on Windows. To this point, .NET Core has been very command line and web server focused. Now the idea is great. You have a WinForms app, you want to run it on .NET Core, awesome. We want to make that possible. So these repos are new and they're getting a lot of activity as internal Microsoft devs and external folks are going in and pushing changes. Another newish and exciting project is ML.NET for various machine learning needs. You can making it easier to do machine learning tasks from within C# or .NET languages. So a ton of stuff, and again, that's not everything. Oh, I forgot, ASP.NET Core is also open source. They have a variety of interconnected repos, but all of that lives in the open on GitHub, just like everything else that I'm showing today. So we use GitHub, shocking. I just showed you like 100 GitHub tabs. GitHub is a major home of open source on the web, right? All of our stuff has been on GitHub for a very long time. And specifically longer than Microsoft bought GitHub for. So we put source on GitHub because GitHub is where open source lives, not because it's a Microsoft tool. So we use GitHub. A bunch of other things happen in an Azure DevOps instance. Azure DevOps used to be called Visual Studio Team Services, used to be called TFS a long time ago when it was primarily a box product. Specifically, we use that for pipelines, which is a build infrastructure. We use it for repos for internal clones of things. We'll talk about that in a little bit. We do occasionally use Azure DevOps for bug tracking, mostly for if we've got a secret bug, like specifically a security bug, right? Those are bugs where you don't want to file a bug where everybody can see it before it is fixed because you want to be able to fix it and have a patch and say, there's a whole security vulnerability disclosure process. All of that happens in the normal Microsoft ways for .NET Core code and open source code. So what happens is we have an internal mirror of everything where you can file bugs and track the progress of things and also make private fixes and get those ready so that you can say, here is a release. It fixes this bug that you didn't know hopefully existed until today. There's also a custom tool called Helix that's does some machine management. Most folks won't need this. Where it comes in really interesting for .NET Core especially is the cross-platform and especially cross-architecture support. There's no easy way to get like an ARM64 machine in the hosted Azure DevOps environment. That's not something that's currently provided by the Azure DevOps team. But we want tests to run on ARM64, so there's a system that allows you to manage those machines. I'm not going to talk about that a ton today, but if you have a massive, heavily cross-platform set of repos, you might have to have something like that as well. So what is the life cycle of a change, right? You've got a bug fix, you've got a proposed feature, what happens to do that? As with most software development processes, it starts with a bug. GitHub calls them issues, so somebody files an issue. The team that owns whatever project it is will triage it and say, yeah, that's a bug that needs to be fixed, or, oh, this is not a bug, we're going to go ahead and close it. This is actually as designed for these reasons, the usual bug triage process. And then someone's going to start working on it, right? If you're a community member, you can say, hey, I would like to start working on this, and one of the team members will say, okay, it's yours, or this other person already called it, or we really want to handle this internally because it's complex and requires talking with 12 other teams, or whatever. But in general, like we're happy to get contributions. We're happy to have folks work on stuff. So then whoever's working on it, going to fire up Git locally. They're going to create a branch. They're going to make whatever changes they need to make, hopefully with tests. and get everything ready to go. And then they're going to create a pull request on GitHub. After that, GitHub has a system called checks that will go in and run a bunch of checks on that code. What this usually means, this is usually what you call like CI, continuous integration kind of test, like pull request testing. We're going to walk through what that looks like in practice in a little bit. And then folks are going to, the core owners of the product will go in and say, okay, yes, like this looks good, we can sign off on it. Different repos have different policies on like the fine details of all of these things. So for example, in my repo, we don't test building stuff on ARM64 as like a normal core test operation. So our checks doesn't have anything that runs on ARM64. And like we have different policies about like what does it mean to get sign off? Do you just need one person who has commit access to say, yeah, that's good enough? Do you need two? That's fairly common. For some things we'll talk about later, you need like a whole bunch of people to agree, but for good reasons that we'll talk about. So after they get signed off, then the PR gets merged and it gets pulled into the whole process. So let's take a gander at what that tends to look like. Here's a pull request that I randomly found when I was putting this together. It's not particularly special. So here's the pull request. This is from a core contributor, so the description of the pull request is perhaps not as verbose and delightful as we would like it to be ideally, but it's pretty good. You can see in the GitHub UI, here's the actual diff, the changes that were made. And then if we scroll down, this is a not logged in view that I'm looking at here. So it's a little harder to look at the actual checks, but if you click on this little check next to the commit, you can see that it ran two things. The bottom one here is easier to explain, so we'll do that first. There is a contributor license agreement required before you can contribute to Microsoft's open source projects. This is common for a lot of big companies that have, or a lot of companies in general that have open source projects. This is protection that you don't come back and say, hey, you used my code without permission, right? The idea is you're contributing this code to us, so you need to license it in such a way that it can be used by Microsoft and also by all the users of the open source project. Most big open source projects have something very similar. It's here. You don't have to do anything proactively about this. If you submit a pull request, a bot is watching and will say, hey, looks like this is your first pull request. Can you please go to this and digitally sign this agreement? And you can go do that. One thing to keep in mind, if you're on your company time and you would like to make a fix in open source anything, is make sure you run it by whatever your legal entity is, and that you're not going to get fired for signing this agreement that says my company agrees that it's okay for you to use this code. It's there to protect everyone, right? And that sometimes holds up pull requests. People will say like, oh, okay, I need to sign the CLA, which means I have to go to my company's legal department, and then they have to figure out whether it's okay. They tend to come back with yes, but it tends to take a little while. But this is part of the process, so we do it. So then the other thing here, with a little rocket next to it, that's the Azure DevOps Pipelines icon, is the checks that were run on this build. So I have those pulled up. Who in the room uses either Azure DevOps or TFS of a recent vintage? Anyone? Cool. So like on-prem or cloud? Cloud? Anyone? Cool. So if you're still on-prem, think about going to the cloud. It's cool. That was my old team, so no pressure. So this is what that view looks like. So here's an example of the ASP.NET Core CI job, and it does a ton of stuff. It builds for Windows. It builds for Windows on ARM. It builds for Mac, it builds for Linux, it builds for Linux on ARM, it builds for Linux on ARM64, all these kind of things we were talking about. And it runs a ton of tests. How many tests, you ask? Well, let's go to the test tab. 100,000 tests. Now, a lot of those, it's the same test, run for Windows and Windows on ARM and Windows on, and Linux on ARM64 and blah, blah, blah. So it's probably not 100,000 actual tests, but a ton of tests. We've got a bunch of these. And it tends to be that these aren't all the tests. Most PRs in most .NET repos don't run performance tests. Those tend to be a lagging thing unless you opt in and say, like, I think this is a performance-related change. So there's even more tests after this, but this is what we were willing to run during the build. You always have to manage turnaround time to get a result versus completeness. So in this case, this job took about an hour to build all those things and then run those 100,000 tests. In this view, when something goes wrong, actually I've got one here. So here's another PR that my boss made. He said he was gonna watch the stream and heckle me, so I'm gonna get a little revenge. So it's not his fault, it's a flaky test. But here's an example of this thing failed. And you say, okay, well, it failed, that's not very helpful. But you can click and you can get the console output of what happened. So you can see what happened. And also, if you go to the test tab, you can see, oh, here are some failed tests. Drill in and get some information about the details of the test. Here is, here's the line that failed in assert. This is the exact test. This is the runtime environment, that sort of thing. So hopefully, if you do submit a PR that causes a test to fail, it's easy enough to figure out, oh, this is what has gone wrong. We've had varying levels of success with that. Bugs about like, hey, I can't figure out what went wrong. Can you change the infrastructure to make it easier to figure out what went wrong? They're welcome in my repo. I don't know. I wouldn't say go file those bugs on everybody that's in the .NET org or anything like that. So the other thing is Azure DevOps has recently announced that it's free for open source applications. So we're part of Microsoft. Azure DevOps is part of Microsoft. We're using it, right? But also if you have any repo on GitHub, are welcome to use hosted build time in Azure DevOps to get CI for your open source build across Windows, Mac, and Linux for free. It's pretty sweet. If you have open source stuff, you should check that out in pitch. So that's kind of the view. When you come in, let's see, where's my, if I come in, for example, in another test, the view I see as a maintainer is here, checks have passed, but in this case, not enough people have signed off. So I can't check. And then when you get enough sign-offs, this big red button turns into a big green button, and somebody that has commit access can go in and push it according to whatever policies are going on. So all of that is like when you're working on something and it's not urgent. When it is urgent, when a release is coming, the process is a little different. Oh, right, all right, so we'll do this. When a release is coming, the process is a little different. All right, so it's all this stuff, none of that changes, except you need like a whole bunch more approval. So the usual way this is done across most teams at Microsoft, there's a lot of differences in details, but the overall process is pretty common, is when it comes time for a release, you'll fork branches and say, okay, like this is going to be the release branch for, say, .NET Core 3.0 or for Visual Studio 16.0 or whatever. And then as the ship date gets closer and closer, you have to convince more and more people that your change is a good change to go in. Long history has shown that the person who's making the change swearing up and down that it couldn't possibly cause any problems and it's just a typo fix or whatever is not a solid basis for changes. So there's an entity, usually a meeting called Tactics or called Ship Room or something like that. For .NET, it's usually called Tactics. And basically what you have to do is you have to bring your bug and say, like, I have a really bad bug. It totally deserves to be fixed now. When it's not too far away from release, I have to convince my boss's boss that it needs to go in. Once it gets really close and the tactics meeting is involved, I have to convince his boss and maybe his boss, and also all of the other people at like my boss's level that this is a good change. And you have to come ready to answer questions like, how did this get slipped through until this time? What are we doing to make sure this never happens again? You know, and have you verified that 100% that like this actually fixes it? Have you given a private build with your change to someone affected by the bug and proven that this fixes things? Have you run functionality tests on things that shouldn't be affected by your bug, by your change, but might conceivably be, so that we can validate that nothing else has changed? All of this is to say that when you send a PR, there is some process that may decide, okay, we are not going to take this for the next release. We're going to hold it for a future release. Even if it's a beautiful, great, wonderful, we totally want it change. You're not sneaking any typo fixes past that whole process on like the day before release, because there's just too much risk in changing anything. Like I say, that's fairly typical. That's basically how Visual Studio's release process works as well. That's how .NET's works. Windows is pretty similar when it comes to the time of release, or at least it was like 10 years ago when I was in Windows. I'm sure it's fairly similar now. So that's one level of you need a bunch of improvement. As a customer, as a .NET Core user, what I would recommend is you file a bug and convince people that it's really bad, and then let Microsoft employees that are paid to deal with all this stuff, right? You don't need to babysit your bug fix through the whole process. I think that's not a great use of everyone's time. If you can like convince people that, hey, no, this is a really bad bug. And part of the process is, what is a really bad bug, right? Crashes are bad. But crashes that impact very few people, only people that are doing something weird, are less bad than, you know, like literally nothing works. So if you hit a literally nothing works right before release, that's going to get fixed. If you hit a, you know, anyone who uses this when standing on their left foot under a full moon bug, even if it's a real bug, even if it's pretty bad for those people, the triage process is going to consider that impact, and they consider impact and severity in making their decisions. Another kind of change that requires a bunch of approval, even early in the process, is API changes to core libraries. So if you come and say, I have a great idea for a method that should be on every list in .NET, cool, like there's totally potentially room for that, but you have to support all of that stuff forever. And as a consequence, there is an API design review process that you have to convince that, like, no, it is worth adding these APIs. It requires a formal proposal and a formal review process. And then you can propose a PR that says this implements the approved review, whatever. If you just propose, you know, every list should have a solve my specific user's problems as a PR, then that's going to get rejected, right? But there's a process, and community contributions go through this, or community API changes go through this process and get approved all the time. I'm not trying to scare y'all off of anything. There's absolutely ways to get things going for everyone. You don't have to be, you know, especially blessed, but you have to be willing to go through the process, because the processes are there, because we've learned stuff. You know, like we've learned what the cost of releasing an API that wasn't thought through as well as we wish it is, and it's very high. So there's process to try to minimize those and improve, but we also want to make progress, so keep going. There's also a repo called CoreFX Lab. experimental changes go to CoreFX Lab before they come to CoreFX, the main repo, to get things going. So for example, I don't know if y'all have been following the story of Span in .NET Core 2. Span is this type that allows you to, with a little more pain at implementation time, have much better memory use characteristics over some of the normal methods that generate a lot of garbage. It's awesome. It required runtime changes. It required core library changes. And a lot of that was prototyped in CoreFX Lab, which is there to exactly to take that kind of time and effort and make sure that we get stuff right in order to move forward. So I don't really have a slide, but when it comes time to do releases and to do builds, we use very similar technology to all of the stuff that runs on every PR into the repos. We have builds hosted in Azure DevOps. There's a build definition in almost all cases now. It is checked into the repo. So if you come to like the come to my home repo and you look here at this is a build definition. This is the official build definition. This is what runs to produce an MS build package in the official build. And most teams have that. It's semi-replicable. Usually these have secret internal Microsoft processes, like specifically signing. Users of the open source repositories, we love you. You do not get to sign things with Microsoft's primary signing key. We have processes for that, and it requires that only approved, PRs and things like that can go through that whole process. So you can't run this build outside of Microsoft for reasons like that. Also things like you want to upload your symbols to symbols.microsoft.com. That's important for debugging. We absolutely want that, but also you as a random person off the street who doesn't work at Microsoft and have a known Microsoft product can't do that. So all of those things are part of the official builds and not replicable from outside. But we try to build simulation layers in as much as possible, so you can say, produce all that stuff and tell me what you would have run, but don't actually run it in case you needed to debug something on your desktop, that sort of thing. The official builds are built from an internal fork hosted in Azure DevOps. And that's, again, for the security bug fix reasons. That way we can go in and we can say, here is a private branch. It tracks this public external branch, but it also has a fix for this MSRC incident. And then we can build that as the canonical copy of the code and ship from that, and then push all of those commits back into the public world when we make the disclosure of the vulnerability. I don't want to imply that we have a ton of vulnerabilities, right? What we have is a sophisticated process for mitigating anything that does happen. So that's the gist of things. So hearing all this, where I tell you, this is why it's really hard to get changes into some of these repos, I'm sure you're all chomping at the bit to want to contribute. So if you do want to contribute, 1, awesome, thank you, that's great. 2, critical information. Writing code is not the only way to contribute, right? We talked about documentation. Filing good bugs to describe bad behaviors is an amazing contribution to an open source project. All of that is good. And we do take PRs. We're happy to have those API proposals, all of this stuff. It's all great, and we're happy to hear about it. So, you have any other questions? I have one other topic I can talk about, but all right, we're going to talk about. I showed you a bajillion .NET repos. Each of them builds independently. But in the end, we want to produce, here is a .NET Core runtime installer, or a .NET Core RPM package that you can install on a Red Hat based distribution or something like that. How do we assemble all of that? And the answer is there's tooling and automation around it. This is something that's changing now for .NET Core 3.0. In the past, it has been a little more manual than we really liked. Now there's a lot of nice automation that you can go, each build publishes to a system that says a new build of this project is available, and then a system can automatically take that and push pull requests to say, why don't you take that new build in the downstream repositories. And there's also a whole set of automation around that you can come and say now, like I've got this build of the .NET Core SDK, what commit of MS build was in that, what commit of Core CLR was in that, which is a nice property to have, especially if you're trying to debug something down to source, or if you need to do something where you want to build a debug version of something. It's nice to be able to locate the exact same thing. Speaking of, we try to version stamp everything with commit information. Since now, all the source is public, there's no reason not to. You tend to be able to find the SHA of a commit if you right-click on a DLL and go to details. You should be able to find all those things. We also use source link technology, which is another open source Microsoft project. I think it may not have started at Microsoft, but it's a .NET project now, which is basically like if you're in Visual Studio or another debugging application that understands the protocol, SourceLink will allow you to just download the right version of a file. So if you say, I want to set a breakpoint on this function by name, potentially, because you see it in a call stack or something, and then you load that up in the debugger. If everything's working smoothly, and it tends to, then even if you've never cloned that repo, don't even know that repo exists, a lot of the time Visual Studio will just pull up the source and give you that the exact commit that piece of code was built from, which is awesome. So that's something you should consider for your own projects, especially if they're open source, because then there's very rarely any reason. If they're closed source and privately distributed, like your code only lives on your servers, then you should probably do something like that as well. If it's closed source and publicly distributed, then things get a little wonky. You can potentially give links that only work for people that can log into your servers, but that's not necessarily the best idea. So that's something to go off. Okay, questions? All right.